All right, so we're doing this problem out of 8.2, number 6. Find the inverse Laplace transform of this thing. And then Cody's worked on this a little bit already, I think. So maybe he has some words of wisdom for us.
Had no luck doing it by hand, but was able to do it with the matrices on my calculator.
Oh, okay. So let me show by hand then, I guess. Can you guys stop drawing?
Would it be more useful for you to show us like the basics of the matrix on a calculator? I've done like very basic stuff with it, but not further than that. Would it be that much more helpful?
I will happily show you the matrix method here in a minute too. Yeah. Let's see. So, first setup maybe. Can everyone mute their mic so I don't get any feedback here? Okay, so first things first, setup-wise, I need to try to factor these. If you spend a minute, they won't factor, which kind of is annoying. So you complete the square on them. You can discover they won't factor by checking the thing that's under the square root in the quadratic formula. B squared minus 4ac. In the case of the kind of left-hand one, right, that's 4 minus 4 times 1 times 5, okay, which is smaller than 0. So that's an irreducible quadratic. The other one, the same thing holds. The right-hand one is 4 minus 4 times 1 times 10. Similar issue, right? So that makes this completing the square into s minus 1 squared plus 4. And that makes this one s plus 1 squared plus 9. And the reason I'm completing the square on things like this is I'm looking in my Laplace transform table and I'm thinking about the e to the lambda t sine or cosine of omega t lines. Does that make sense, guys? I told you all to mute your microphones and then I ask you questions.
So, yeah, it does make sense.
You guys see the lines I'm looking at?
Mine is incredibly delayed. Like, I think you've written a lot and I can't see anything.
Oh.
You're still on the bubbles. Like your
Bummer.
little thought bubbles.
We might just need to zoom out.
Yeah, I wrote some stuff off to the right-hand side. Oh, but I wrote some stuff underneath the bubbles, so if you're not seeing them, you're just incredibly delayed. Let's see. I'm going to give you another option other than Stormboard. I'm going to go live in the background here.
A what?
I'm going to share my screen in the background so you can, if you want to try looking at my screen through Discord instead, that might be better.
Yes, please. Thank you.
Okay, so at any rate, I'm thinking about these kind of sines and cosines, maybe with e to the lambda t things. And so that if I'm looking at those two lines look like s minus lambda over s minus lambda squared plus omega squared. That's the cosine one. And then the sine one looks like omega over s minus lambda squared plus omega squared. So those are kind of my goals to reach, is those. And what I have currently does not look like that. So if I'm going to try to set up a partial fraction kind of decomposition, which is spelled F and then D. So if I'm trying to set up PFD for this, I'm going to set this as 17s minus 15 over my stuff, right? is going to equal, and then I need to set it up kind of thinking about this way, right? So I'm going to set this up as A times S minus 1 plus B over S minus 1 squared plus 4 plus C times S minus, no, good. C times S plus 1 plus D over S plus 1 squared plus 9. Does that kind of setup make sense?
We're just factoring it out and trying to solve it to make it look like some of the other Laplace transforms that we can recognize, right?
Yeah, exactly. And I'm doing partial fraction decomposition in a little bit of a weird way, because normally I would have AS plus B, right, and CS plus D on the tops.
But you do.
Well, I have A times S minus 1. Yeah, I kind of pre-factored some stuff.
This is the same thing that we were doing the other day. We're going to have to do the F times S minus A thing.
Yeah, I could do it that way. These two lines happen to already be in the table, which makes my life a little bit easier, so I don't have to do the shifting rules. But you could use the shifting rules. They would get you to the same place. Okay, everybody good with my PFD setup? Okay, so if I kind of think about what I've got 17s minus 15, right, is going to equal A times S minus 1 times S plus 1 squared plus 9 plus B times S plus 1 squared plus 9 plus C times S plus 1 times S minus 1 squared plus 4 plus D times S minus 1 squared plus 4. Pretty good with that whole bunch of nonsense?
Yeah.
Okay, so you have some options now. You can either multiply all this crap out, which is a terrible idea, or you can use the kind of Heaviside Method idea. So in order to use the Heaviside Method idea, I'm going to set S equal to 1, right? And so at S is 1, on the left-hand side I have 2. Is A times 0 and B times 2 squared plus 9 is 13 plus C times 2 times 4 plus D times 4. You guys with me on that?
Yeah.
Okay, when S is minus 1, I'm going to get some more things to kind of zero out. So I have minus 32 is, and when S is minus 1, let's see, I have A times negative 2 times 9 and B times 9 and C times 0 and D times 8. questions, concerns, things? Did I screw up any arithmetic in there? You guys keep connecting and disconnecting?
It's whenever we turn on our mics or off our mics, it makes a bling noise.
Perfect. Okay, cool. So nobody's currently lost, or at least not willing to admit so?
Accurate. Hearing no objection.
I just keep breaking up.
Okay.
Like, you're breaking up on my end to where I can't see your screen or anything like that, or see anything that you're doing.
Oh.
Yeah, mine is like really behind. Like once he stopped talking, all of everything that he'd written was just like boom.
Even with the stream?
Yeah, like I can't even connect to the stream because it won't show the screen. Like it'll just show black and loading, and then disconnect me from the thing, and then connect me back in. And then Joe kept breaking up, so then I'm kind of just listening.
Okay. That's a bit frustrating. Hopefully publishing the video will make things
Can
more...
you hear, though? Like, is your hearing good?
My hearing's fine when I'm not, like, in the video stream.
Okay, because what I
Okay.
can do is I can just keep taking screen grabs and just post them into the Discord while he's
Yes,
talking.
please. That
Yeah,
would be wonderful.
okay.
Thank you.
Awesome. Thank you, Glenn.
Yeah.
Okay, so when S is 0, I have minus 15 is A times -1 times 10 plus B times 10 plus C times 1 times 5 plus D times 5. Okay, so that's 3 equations and 3 unknown, or in 4 unknowns, so I need 1 more, yeah? Okay, so in order to get 1 more, there's a couple moves you can do. One of them is relatively straightforward. And the one you can do that's relatively straightforward is you can just look at the z cubes, because there's not going to be that many of them. Or the s cubes, rather. So the equation for the coefficients for s cubes, there's none of them on the left-hand side. And on the right-hand side, I'm going to get 1 from the a term, and also 1 from the c term, and nothing else. So I have a plus c. Did that thought process make sense? That's a little bit weird. I'm kind of mix and matching methods.
Methods from stuff that we were using a long time ago. So you're just substituting other stuff for things. I'm not sure.
The A plus C is just the normal way to solve partial fraction.
Yeah, so this is, the first 3 are like the Heaviside Method, kind of. And then this one is the usual PFD kind of method. It's just that if I keep using Heaviside's method, I'm going to keep getting equations with lots of crap in them. But the 1s cubed equation from the usual PFD is going to be super easy for me to deal with, so I just got it this way.
Maybe it's because I've watched the videos. Did I miss like somewhere where it said Heaviside or something? Like, because I kind of understand what that is, but
so
really.
The Heaviside method we talked about a little bit last time. It's just this kind of cheater trick that you plug in where the bottom is 0. And so in my case, I have lots of, if you kind of scroll, if you kind of look at my PFD result, I have lots of S minus ones and S plus ones, right?
Yeah.
And so I can make lots of pieces of this thing 0 if I pick S as 1 or S as minus 1.
Okay.
So really, I mean, however you do this, you come up with equations for, you need 4 equations because you have A, B, C, and D, period.
So you're just using the Heaviside method by setting S equal to different things that make different things equal 0 to find A, B, and C.
Yeah, that's all the Heaviside. So the usual PFD method would be I would multiply all this crap out and then equate the coefficients, right?
Yeah.
The Heaviside method is just like, oh, hey, by the way, if you just plug stuff in that makes things 0, then you maybe don't have to deal with this whole like multiplying all this crud out kind of method.
Okay.
In fact, there's probably one better choice even that I could use, which is to like use some imaginary roots to make some crap go away. But that's a little that's harsh. It's way harder than doing it this way.
Okay.
Okay, so at any rate, I have my equations, and I'm just going to organize equations for just a second, right? So top equation has 0 A's in it, 13 B's. I'm sorry, I'm doing this with a matrix. Have you all seen matrix work?
Not really.
Yep.
Okay, so for the not really, all I'm doing is I'm taking the coefficients. I'm going to have A, B, C, D's, and numbers, right? And equals.
Am I right to think that, so whenever I see this kind of stuff drawn out, I think automatically like cross products. Should I completely dissociate that, or is that okay?
Oh, yeah, this is not going to feel like cross products because this is a different matrix thing. So
this is complete dissociation from all of that.
Maybe not complete, but yeah, for right now it's completely disassociated. Later you'll see a connection. But that connection won't matter right now.
Okay.
And it's a little bit deep, so I don't really have time to go quite all the way there. But all I'm doing is I'm stripping the coefficients off. So I'm looking at the first equation, which says 2 equals b times 13, right? And so I didn't have any a's in that equation, so I have a 0 here. I had 13 b's. I have 8 c's and 4 d's. And then my number on the other side is 2. Everybody with that? Okay, hearing none. In the second equation, I have minus 18 is the coefficient on A. 9 is the coefficient on B. There aren't any C's, and the D coefficient is 8. The number on the other side is minus 32. On the S is 0 equation, I have minus 10 in the A's, 10 in the B's. Oops, that's not supposed to be in there. And 5 in the C's and 5 in the D's and minus 15 on the other side. And then in the last row I have 1 in the A's, no B's, 1 in the C's, no D's, and 0 on the other side. Pretty good with this setup? Okay, so then I need to reduce row this thing. And for that, I'm afraid I probably have to go to a different utility or a calculator. So I'm going to post a video on how to do this on your calculator. I have one on the YouTube channel that I'll just link in the description for this video when I post it. But after you re-ref it, you're going to get... can someone do this for me too?
It's 1 0 0 0 1 0 1 0 0 2.
Hang on. 0, 1, 0, 0, 2.
It's
I know
less
it's
than
the
normal,
identity matrix.
And then it's -1 and -4 at the end.
Okay. Perfect. Okay, so for those of you who haven't maybe had a ton of matrix work, it doesn't really matter what the hell this means, except that these are in the A, B, C, D numbers columns. And so that...
This is now how we're going to solve for A, B, C, D by making A times 1 equal to 1, B times 1 equal to 2, and is that right?
Yep, perfect. So A is 1, B is 2, C is -1, and D is 4.
Rad.
Cool. So this reduce row thing is pretty clutch. The only caveats to using that are that you have to have equations that look like variables on one side and equals in the middle and numbers on the other side.
So we could have done something like this, where on the left side only numbers, it's all the other long strings of stuff in algebra that we were doing earlier in the earlier sections.
Yeah, you can do this anytime you have a linear equation, right? So a plane, right, or a hyperplane in A, B, C, and D, and equals a number. So anytime you have a bunch of...
We have to do the Heaviside stuff, right? So we have to set it equal to different numbers?
You don't have to do the Heaviside stuff. You need to get these equations from somewhere, and the Heaviside method is the quickest way to get these equations.
Okay.
In the case that you have linear terms, the Heaviside method is hella fast because it just gives you answers. In the case where you don't have linear terms, like in this case I have irreducible quadratics, it's a bit more inconvenient, but it still works. So basically, get the equations from somewhere, put them into a matrix, ref that matrix, that gets you your coefficients, and then going back to your original, right? I had 17s minus 15, right, over some stuff. And now I'm saying that's equal to, let's see, A is 1, and A was over, going back up to look, A was times s minus 1 and then over s minus 1 squared. So that was 1 s minus 1 over s minus 1 squared plus 4 plus, and then B is 2, and that's over s minus 1 squared plus 4. And then I had -1 times s plus 1 over s plus 1 squared plus 9. And then I have plus 4 over s plus 1 squared plus 9. Okay, everybody with me to here?
Yeah.
Okay, so now I need to inverse Laplace things, and this is where life gets a little tricky, because I have my my Laplace things written way up here. I'm gonna grab these and copy this. Whoa. And paste it. Uh-oh. Okay, I'm stealing something from the top.
Did you already choose one for them?
Did I already choose what?
He said that they look the most like the cosine and sine e to the lambda t ones.
Yep.
Yeah, e to the lambda t cosine and sine.
Yeah.
Omega t.
These screen grabs helping anyone, or should I stop?
They're helping me. I can actually see it now.
Okay, cool. Sweet. I'll keep going then.
Thank you.
Mm-hmm.
Okay, so I have these two lines that I'm writing in red from my Laplace table. Right? And now I'm going to think about this first one, right? So I have s minus 1 over s minus 1 squared plus 4. And I'm thinking that looks an awful lot like an e to the lambda t cosine omega t, right? So that makes me think that 1 is lambda and 4 is omega squared. And that makes me think that the first thing, right, this guy, inverse Laplace transforms to e to the 1t cosine of 2t. Everybody with me on that?
Yep.
Okay, now this dude here is supposed to look like a sine, I think. And so I'm looking at the bottom here and I'm thinking, okay, so lambda is 1 and omega is 2. And I'm supposed to see an omega on the top, which I do. And so I think this thing, inverse Laplace transforms to e to the t sine of 2t. Okay, and then these are where things are going to get a little harder. Okay, so next, I have s plus 1s. That makes me think that lambda is -1. And this 9 makes me think that omega squared is 9, which means omega is 3. Everybody with me? Okay, where does the -1 go?
Gonna just make the whole thing negative.
Yeah, good. Use linearity to
Just
pull it out because you don't
Yeah.
need it. So I have minus, right? And then otherwise this is identically an e to the minus t cosine 3t. Okay, now this other one's going to be the hard one because this one's got some constant adjustment that I need. So I'm looking at that and I'm thinking the same thing, right? I'm thinking lambda's -1 and omega's 3. But I'm supposed to see an omega on top here, right? So I'm supposed to see a 3 up here.
Pull out the 4, multiply by 3 1/3.
Perfect. So I'm going to take this 4, I'm going to pull it out of the Laplace transform, and then I'm going to divide by 3 while I multiply by 3. So I'm going to have a plus 4, crummy 4, plus the 4 that I pulled out over a 3 that I needed to compensate, and then an e to the minus t sine of 3t. And that is the Laplace inverse of the stuff I started with. Does that make sense? That is a kind of super involved problem. Thank you, Glenn.
Yeah, that was crazy.
I understand PFDs now.
Cool. So the matrix trick is one that's not to be undervalued. So I'll put the video in the link for the description. If you need it, if you don't happen to have a TI whatever calculator,
I think TI 83 is enough. I'll do it. So
yeah, there is a thing called Wabbit EMU that will let you make a smartphone or tablet pretend to be a TI whatever calculator.
can you turn off your stream, Joe?
Yes, I can.
Hella choppy.
Okay. Let's see. So I'm going to pause the recording before I do that.